Greetings everyone. Today we're going to explore expanding and condensing logs. This process is going to help us better solve more complex logarithmic equations. You should have a foldable from class. If you were absent for any reason, you don't need the foldable. You can just take it in your own notebook. So let's take a look at the three properties that we're going to use today. The first is called the product property. If you need to pause this video to write it down, and then you can pay better attention. The product property says that if we're multiplying two values of a log, we can expand that into addition. So what we're going to do is this is almost like a conversion property. So we're going to convert back and forth. Now the way I happen to have these written, if I'm going from the left to the right, that's expanding, which makes sense. I'm going from one log to two logs. If I go to the left, we're going to use the word condense. I'm going from two logs down to one log. The quotient property. Pause this if you need to before we continue. The quotient property shows that division converts to subtraction or subtraction to division. Notice that the value in the numerator becomes your first value, and then value in the denominator is your second value. Again, if you need to pause this to write it down, the power property says that if I have a log of a to the b power, so this would be all of these are common log right now, meaning base of 10. If I have log base 10 of a to the b power, I can take that exponent and it can become a factor out front. So I'm going to multiply by b. Or if I have a number out front, it can condense and become the exponent. You don't have to write this down, but let's talk about where do these rules come from? How does adding and multiplying relate? Well, when we look at our exponent rules, when I have like bases and I multiply them, I add the exponents. So we've had this property before. Addition adds the exponents. So these are very much related, and we can go in more depth if you have any questions. The rule of subtraction says if I have like bases that I'm dividing, I subtract the exponents. And when we talk about multiplying exponents, that's when I have to distribute an exponent onto an exponent, so power of a power. And that's when we multiply. So all of these properties sort of correlate to logs. And again, more specifically, we can go in detail if you have any questions. Inside your foldable or in your notes, let's look at several examples. We'll go through each property individually. So to start off on this first property, currently it's saying I'm multiplying these two values. So that means I need to expand, as it says, to two logs. Each of them keep their base value. I have a 5 and an x. They each get their own log, and because it was multiplying, it becomes adding. In this case, I'm multiplying three values. So I'm going to have 3 logs. Now, because it's a common log, I do not have to write the base of 10. Because I'm multiplying all of them, they're all going to become addition. Let's go in the reverse. Let's condense, meaning I'm going from 3 logs down to 1 log. Keep the common base. Because all of these are being added, they're all going to be multiplied. Anytime you can take care of any simplifying, you must do that. So in this case, I would take 7 times 11 first, 77, and if I double that, I arrive at 154. Let's take a look at the quotient property. First, I'm going to expand. I have a term over a term, so I'm going to change it to 2 logs. Because I'm dividing, it becomes subtracting. What's on top comes first, what's on bottom comes second. Let's go in the reverse. Let's condense. I have 2 logs, so I want to condense down to 1 log. What's first goes on top. What's second goes on bottom. It's common log, so I can write a 10 or leave it. But no matter what, you always reduce any numerical values that you can, especially fractions. Let's take a look at this one. Again, I'm going from 2 logs, so down to 1. Common base of 4. What's first is on top. What's second is on bottom. Let's take a look at power property. My first suggestion is to take care of exponent rules first. So for example, here I see that I have parentheses to an exponent. So I have power of a product. Because it's being multiplied, I can distribute that too. So I'm going to do that first. So I'm going to have a squared and b squared for that log. Next, I'm multiplying 2 terms, so I'm going to change it to adding. So I'm combining a few properties here. So 1 log to 2 logs. It's multiplying, so it's going to become addition. Now I have a power. That exponent becomes a factor out front. So I'm going to have 2 log base 4 of a plus 2 log base 4 of b. So again, take care of those exponent rules first. That way, if there's any numerical values, you can take care of them and simplify them. We've expanded. We have nothing being multiplied within the log. We have nothing being divided within the log, and we have no exponents. So I've expanded all the way. Ooh, here we have to take care of exponent rules first. What I mean by that is I have square root of 7. We have to remember our rule of e over I was the little shortcut we created. Meaning my exponent on that 7 is 1. The index, because it's a squared root, is 2. So this is the same as saying 7 to the 1/2. If I was to rewrite that just so I can see that a little clearer, I would have log base 5, 7 to the 1/2 times x. I'm multiplying 2 values, so I'm going to have 2 logs of log base 5. Multiplying, so it's going to become addition. I'll have 7 to the 1/2 and an x. I can't leave any exponents if I'm expanding, so now I'm going to have 1/2 log base 5 of 7 plus log base 5 of x. Now notice only the half goes to the 7, not the x, because that radical was only over the 7 to begin with. So that would be my final expanded log. Let's do the reverse and let's condense. So first of all, I have a 1/3 out front. Anything out front becomes an exponent. So we're doing the reverse. Here we had exponent. In previous examples, the exponent went out front. Well, now it's out front, becomes the exponent. If you can simplify 6 to the 1/3, well, you can. If you went from radicals to exponents, then you got to go exponents to radicals for condensing. Remember the shortcut, e over I, exponent over index. Now, if you can actually reduce that, please do so, but 6 is not a perfect cube, so I can't take it any further. So that would be my final log. Now, let's try combining multiple properties into one example. To start off, take care of exponent rules first. This is just going to help us in the solving process in our next lesson. Some of the activities that we've had in class might not distribute the exponent first, so just be aware they might kick it out front and leave it there when they're expanding. So just be able to see both sides, meaning put the exponent out front of the log or distribute the exponent first. You have to be able to participate in both. So first of all, I'm going to distribute that 5 to everything in the parentheses, meaning I'm going to have 6 to the 5th, x to the 5th, 11 to the 5th. We have a couple of options here. You can take care of those numerical values, or you can start using the properties. The first thing I'm going to do is I'm going to take care of the properties. If I take a look, on the top I am multiplying two values and then I'm dividing by one value. So that means I'm going to have 3 logs when I expand. The logs that I am multiplying up top will become addition. The log that I am dividing by will become subtracting. So notice the adding becomes the multiplying. Anything beyond the subtraction sign should be from the denominator. So again, on some of the activities, they might kick these 5s out front. So just be aware of that. You might see that as some of the multiple choice options. I would like you to take care of simplifying that 6 to the 5th. It's going to help us with solving later on. So I'm going to have 7,776. Here, this exponent does have to go out front because I can't simplify x to the 5th. So because I'm expanding, that would go out front. It's my new factor that I'm multiplying. Next, I have 11 to the 5th. Yes, it'll be a big number, but let's take care of that. I won't give you any that large on any of the activities. So if I take a look, I know I've truly expanded if I have no multiplying, no dividing, and no exponents. So that would be my final answer. Let's look at condensing. So first thing I notice is I have a number out front. So that should jump up and be the exponent. Now I'm writing each of these steps out individually. If you can see multiple properties in one, feel free to take care of 2 properties or 3 properties at once. I'm going to show each step here. So first was factor to exponent. Next I see I'm subtracting 2 logs. So I'm going to have 1 log with a division bar. What comes first goes on top. What comes second goes on bottom. I have been asked the question if we could take that value and just pull that exponent out and say to the 4th like this. If you were to do that on a test, I wouldn't count it against you. You're actually taking it a step further. It's not necessary. I'm okay if you leave it this way. So in this case, this would be my final condensed answer. So let's talk about why we're even learning this, expanding and condensing. In the future, we're going to solve more logarithmic equations. Well, when I have 2 logs on one side, I can't solve that. So I'm going to have to do a little bit of work to condense first in order to solve. So numbers or factors out front become exponents. Subtracting becomes division. And then I can convert. So then I can do exponential form of 10 to the 16th equals 3 over x squared. Now I can actually solve that for x. So that'll be the next lesson. That's what we are preparing for. So you want this transformation of expanding and condensing to become a smooth process so that solving is an easier process as well. Let's take a look at just one more quick example. You don't have to write this one down, but it will help you on some of the activities we're going to do. I've had some questions concerning what if I have multiple values within the division. So if I have something like this, and let's give it a log base 5, and let's do a 2 and a 3. Okay, so I'm going to try to make this more complicated. This is going to be a large expansion. But what matters is that I have 2 values on bottom and 3 on top. So first of all, I would take care of distributing that 2 to all 5 terms. Okay, it's power to a power. So I'm going to distribute to all. I'm going to have 4x squared y squared, and I'm going to have 9z to the 6th. Power to a power, you multiply. Now what I can do is each piece on top that's being multiplied is going to become addition, and each piece on bottom is going to be subtracted. So technically I have 5 terms, so I'm actually going to have 5 logs. So I'm going to write that out first. The first 3 are being multiplied, so that's pretty straightforward. You're going to change that to adding. But then a lot of students have questions about the following logs. So I'm going to fill in, I know I'm going to have log of 9, I know I'm going to have a log exponent of 6. Now I'm dividing by all of this, so I'm subtracting all of this. I'm multiplying the 9 and the z, so that would become adding. Now, we don't really want these parentheses, so technically I'm going to distribute that subtraction sign. So it looks the same as log base 5 of 9 subtract log base 5 of z to the 6th. So you can either think of it as subtracting all of it and then distribute the subtraction sign, or I look at it as I'm adding, I'm adding, I'm adding, I'm subtracting, I'm subtracting. That's how you can separate the top and bottom. But now I also have exponents, so those are going to get kicked out front. So my final solution on this would be log base 5 of 4 plus 2 log base 5 of x plus 2 log base 5 of y minus log base 5 of 9 minus 6 log base 5 of z. So notice those with the subtraction signs were on bottom, those that are positive were on top. So watch out for those that are very much multi-step and make sure you use your signs correctly. Check Google Classroom for your assignment. Let me know if you have any questions, and we'll see you next time.